Okay, I'd like you to start this video by doing a practice problem. So pause the video, solve this logarithmic equation right here, and then start the video up again and check your work. So this is a logarithmic equation. We have logs on both sides. So we'd like to set it up so that each side has just one logarithmic expression. So the left-hand side is all set. The right-hand side, we're going to use the quotient rule. The difference of two logs is the log of the quotient. Now we have a single log on each side with the same base. We can set the arguments equal to each other. From the property, it would be like setting m equal to n. We've got a rational equation that resulted, so I'm going to multiply each side by the LCD. That cancels, leaving me with a quadratic equation, x squared plus 6x plus 5 equals x minus 1. Subtracting x from each side gives us x squared plus 5x, and we add 1 to each side, we'll get plus 6 equals 0. We're going to factor the left-hand side. Again, you can use a quadratic formula if you prefer. We're going to set each of these factors equal to 0. And we can see here that if we go to check them, both the -2 and the -3, when substituted in either of the log expressions on the right-hand side, basically create a negative argument, meaning that these two values are not in the domain of this equation. So there's basically no solution. Now when you have a solution, it's fairly reasonable to check it by just substituting. When there is no solution, sometimes you want to just be reassured that you didn't make a mistake. So we can use our calculator to kind of confirm, or at least give us a better idea of whether this makes sense, that there's no solution. Now let's check this on our calculator. I'm going to type in the left-hand side of the equation in for y1. So it'll be the natural log of x plus 5. And then in y2, I'm going to type in the right-hand side of the equation, which is the natural log of x minus 1 minus the natural log of x plus 1. And if these two, if the two sides of this equation, if they have a solution, there'll be an intersection of these two graphs. So I'm going to do a zoom 0. Zoom 0 is actually zoom fit. So it's graphing the first equation, it's graphing the second equation, and I'm going to zoom out a little bit so you can see a little bit farther, a little bit more of that window. You have to hit enter twice when you zoom out. There's one equation, there's the other equation, and you can see that they're not going to intersect. It almost looks like they're parallel, but they're not going to intersect each other. So that can give you a little more confidence that your answer is correct.